Okay, so today we are going to be learning about um, whether or not we only ever have one solution to an equation. So in the linear equations we've been working on, there is just one solution. We find the value of x, or whatever the value is. X equals, 7, or whatever it is. So we've been working with linear equations. Linear equations are equations that have one variable. That means that they have the variable that is never raised to a power, not x squared or anything. If we were to graph the expressions that we've been working on, you would get a line. That's why we call it linear, because linear means it's a line. All right, so what is the deal? Do all equations have just one solution? And hopefully you have your notes open, because you're going to be wanting to write this down or type it up. Some equations have just one solution, like this one. So let's go through here. What's my first step? That would be distributive property. So I'm going to distribute. Negative 2 times 3x is negative 6x. Negative 2 times negative 2 is, what's negative times negative? Yeah, positive, and 2 times 2 is 4. And then over here I have negative 5x minus 1. Now I'm going to get rid of my lowest variable term. That would be this negative 6x. I'm going to add 6x to both sides. Gives me 4 equals x minus 1. Add 1 to both sides, and I got x equals 5. I'm going to check it. 15 minus 2 is 13. That would be 13 times negative 2 would be negative 26. Over here, negative 5 times 5 is negative 25. Minus 1 is negative 26. So, yeah, it's the right answer. So the only value of x, the only number we can plug in there for x that will make both sides of this equation equal, is x equals 5. There is one solution to this. One solution. When you have one solution, you have an equation that has only one solution if only one value of the variable makes the equation equal on both sides. So, one solution is when you find a value for x. X equals something. You're going to get x equals, and then some number. I'm going to call it n. And I'm going to show you a trick a little bit later on how you can kind of tell at a certain point when you're solving. So I said that some equations have only one solution, but what about other equations? Well, what if we set the two expressions from the starter, and hopefully you did your starter, equal to each other and create an equation? What happens then? So let's look at this. I got 3 times 4s. I'm going to distribute, obviously, so that gives me 12s. Actually, on the starter it was x, but, bear with me. Plus 3 times 8 is 24, equals 2 times 12 is 24, plus 2 times 6x is 12s. Okay. So I'm going to get rid of one of my variable terms. I think I'll get rid of 12s here. Oops, 12s over here and 12s over here. That cancels, and I have 24. But this also cancels, and I have 24. What does that mean? We didn't find a value for s, did we? We really didn't. This means that any value of s will work. No matter what we use for s, the two expressions will always be equal. I can plug anything in there. We know that when we did the starter. We plugged in different values for x on the starter, and they all worked in both expressions. So, here's what you need to know. Any equation that, when you solve for the variable, results in a true statement like 24 equals 24, has an infinite number of solutions. Any number, any positive number, negative number, fraction, decimal, irrational, any number will work. Anything you put in there. And 24 equals 24. That's a true statement. Could also be x equals x. You might see that later. So as long as the two sides of the equation are equal, you have an infinite number of solutions. Sometimes I call that all solutions, because absolutely anything will work. So on our notes, infinitely many solutions. An equation has infinitely, many solutions if any value of the variable makes the two sides of the equation equal. One of the ways you can tell is you get a true, write this in your notes there below that. You get a true statement like 24 equals 24. And again, I'm going to talk about a little trick after we talk about this next thing. Okay, so is that all? Well, no, because there's also a scenario where you can get no solution. There's no number that will work. So let's try this one. 3 times 2g is 6g, and 3 times 4 is positive 12, and we have 6g plus 9 over here. Now, I got 6g, and I'm going to subtract 6g from both sides to get rid of this variable term, but look, it gets rid of that one too. And I'm left with 12 equals 9. And 12 is never going to equal 9. So this equation does not have a solution. It results in a false statement because 12 does not equal 9. No matter what you put in there, it's not going to make 12 equal 9, ever. So there is no solution to this equation. So what do we need to remember? That when you solve an equation, if the result is a false statement, there is no solution to that equation. No solution. An equation has no solution if no value of the variable makes the two sides of the equation equal. When you solve it, you get a false statement, like 12 equals 9, which we know is not true. Now, I want to talk to you a little bit about a little bit of a trick. When you get to the point where you've simplified both sides as much as can happen, then you are going to have something like 2x plus 3 equals 9. Well, actually, let's do this. 4x minus 3. Okay? Here you have different variable terms. 2x and 4x. Very different variable terms. This is going to have one solution. If the variable terms are different at this point, when you've simplified as much as you can, you've done distributive property and you've combined like terms, if the variable terms are different, you're going to have one solution. But if the variable terms are the same, right here, the same, you're either going to have infinitely many or all solutions, or no solution. So then you look at the constant, and I'm doing a squiggly line when I should do a straight one, because constant, we do squiggly for variable term. So constant term, constant term, constant term, those are the same. So that's all solutions, or infinitely many solutions. And if I have this same kind of thing, only now I have my same variable terms, but now I have different constant terms. That tells me that there is no solution. So this is the trick I was talking about. After you do the first two steps when you're solving an equation, if you have the same variable term on both sides, then you're going to either have all solutions or no solutions, depending on if the constant's the same. If the constant's the same, you have all solutions. If it's different, you have no solution. If the two variable terms are different, then you're just going to have one solution. So that's pretty tricky, I think. So let's see if we get it. We're going to try some. These are on your paper. I want you to write them in the right column on your paper, or type them, or, you know, whatever you need to do on Cami. Okay, so the first one we're going to look at is x equals 2/5. Do we have the same variable term on both sides? No, we do not. Do we have a value for x? We do. That's one solution. X equals 2/5 goes in one solution. Okay, next one. 1/2 equals 5/10. Does 1/2 equal 5/10? Yeah, 5/10 is 1/2. So that's a true statement. What does that mean? That means that our constants are the same, all solutions, or infinitely many solutions. Okay, 2/10 equals 0.02. 0.02 is not 2/10. 0.02 is actually 2/100. So is 2/10 and 2/100 the same thing? It is not. Not true. No solution. Okay, I get to this point, 2j plus 7 and 7 plus 2j. Notice, I have the same variable term on both sides and the same constant, both positive 7. So what does that tell me? Infinitely many solutions is correct. Okay, this one, 3h equals 12. I only have a variable term on one side, not the other. That tells me my variable terms are not the same, so that's one solution. That solution would be h equals 4 if you kept working. 4 equals 9. True or false? False. No solution. 4 is never going to equal 9. And 1/2 equals 2/3. Does 1/2 equal 2/3? Are those the same thing? No. Again, false statement. No solution. So hopefully you had time to type those in, or you can pause and get that done right now. And we're going to move on to look at some more examples. So we're going to try some real equations. We're going to simplify both sides and see if we can figure it out at that point. Okay, so I have, you know, multiple guess here, multiple choice. All right, so distributive property and combined like terms. I'm going to kind of do these at the same time. Bear with me. So I got constant, variable, variable here. That gives me 6w plus 4. I could put the 4 plus 6w. It doesn't really matter. Equals, here I'm going to distribute. 3 times 2w is 6w plus 3 times 1.6. 3 times 1 is 3. 3 times 0.6 is 1.8. So that would be 4.8. Now, I can tell from here, I got same variable term on both sides. It's going to go away. I got a constant here and a different constant here. What does that tell me? That tells me no solution. If I kept solving, what I would end up with is 4 equals 4.8. Don't be tempted to call one of those W, because they're not. No W is going to make this work. Okay, next. Here we go again. I'm going to do the same kind of thing. Let's see, I've got distributive property. 4 times n is 4n. 4 times a negative 2. I got a positive times a negative. Is that going to be positive or negative? Negative, and 4 times 2 is 8. So negative 8 minus 1 equals, I'm just going to copy this down because I need to combine like terms on both sides. Okay, so variable term, constant, constant, variable, variable, constant. So on this left side, I'm going to have 4n, negative 8, minus 1. Signs are the same, so I add and keep the sign. I add the numbers 8 and 1, that's 9, and keep the sign, which was negative. So I have 4n minus 9. Equals 5n minus one of those gives me 4n. And then I have plus 9. And look at this. I'm simplified. I got variable term, they're the same. So I know I'm either going to be no solution or infinitely many. Look at my constants. Negative 9, positive 9. 2 different constants, no solution. Because when I subtract 4n from both sides, I'm going to have negative 9 equals 9. That is a false statement. Never going to be true. No solution. Okay. Let's work on this one. So what do I need to do first here? Well, distribute and combine like terms. 0.25, that's 1/4. So what's 1/4 of 4x, or 4x divided by 4? That would just be x. And 0.25 times negative 2. I got a positive times a negative. That answer is going to be negative. And 1/4 of 2 is 1/2. So negative 1/2. And you can check the calculator if you don't believe me. Over here I have x minus 1/2. Aha! Variable term, same. Constant term, same. So what does that tell me? Infinitely many solutions, or I could say all solutions. Because if I subtract x from both sides, I'm going to be left with negative 1/2 equals negative 1/2, which is absolutely true. Always going to be true. Does not mean that x equals negative 1/2. It means that negative 1/2 equals 1/2, negative 1/2, sorry. And x can be absolutely anything. So be careful about that. Kids are tempted when they get this, negative 1/2 equals negative 1/2, to say, oh, well then x equals negative 1/2. No, it doesn't. This does not say that x equals negative 1/2. It says negative 1/2 equals negative 1/2. So be careful about that. All right. This one we have r's. Wow. Looks like we're going to combine some like terms. I got variable, 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 variable. So I'm going to have r equals, I'm going to do this a step at a time. 5r minus 3r is 2r, and I still have this minus r. So I'm going to do one more. 2r minus another r equals r. And look at this. Variable term, they're the same. What is the constant here? I want you to think about that for a second. Does that make sense? Constant is really 0, and your constant is the same. This is all solutions, or infinitely many solutions. On your practice, it says infinitely many solutions, but you should recognize that all solutions is the same thing. So this does not mean that r equals 0. This means that r can be anything as long as r always equals r, which it will. It has to be the same thing. Infinitely many or all solutions. Okay. What am I going to do first here? I'm going to distribute. 5 times 12, if you don't know your 12 times tables, you can count on your fingers. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. 5 times 12 equals 60. 5 times negative d, I got a positive times a negative. Is that going to be positive or negative? Negative 5d equals 2d minus 6. Do I need to finish solving this to know how many solutions there will be? Let's think about this. Here I got constant, variable, variable, and I'm going to do 2 underlines because that's a different constant. My variables are also different, so I could do 2 underlines there. Different variables, 1 solution. And I don't have to solve that to know there's going to be 1 solution. I'm going to solve it so we can see what that solution is, but I wouldn't have to. Okay, first I'm going to add 5d to both sides. That gives me 60, because these cancel, equals 2d plus 5d is 7d minus 6. Next step is to eliminate this constant that's messing up my variable. So I'm going to add 6 to both sides. That gives me 66 equals 7d. And to get rid of this 7 that's messing up my variable, I'm going to divide by 7 on both sides. I cannot simplify that 66 over 7 anymore. So my answer is d equals 66 over 7. I could make it a mixed number, but that is not necessarily more simple. It would be 9 and 3/7. Either one of those is fine. An answer can be a fraction. I know we don't do it very often, but it happens more often than it not in real life. And that's a perfectly good solution. D equals either this or this, which is the same number, fraction. No problem. 1 solution. And 1 more. So I'm going to distribute first. What am I distributing here? Because I see parentheses, but I don't see a number. I see a 7x minus, and then this whole thing in parentheses. I hope that you remember that what I'm really distributing is a -1. So -1 times x. Here I'm going to keep this 7x. -1 times x is -1x, or just -x. And -1 times 5. A negative times a positive is negative. 1 times 5 is 5. Over here, 6x plus 5. Okay? Variable, variable, constant, variable, different constant. Okay, 7x minus x. Well, if I have 7 x's and I take one away, that gives me 6 x's minus 5 equals 6x plus 5. I've simplified as much as I can, and look at this. My variable terms are the same. My constants are different. What does that tell me? It tells me no solution. Because when I get rid of those 6 x's on both sides, it's going to give me -5 equals 5, and that is absolutely false. So there is no solution. There is no number that I can put in there for x that will make this work. Okay, so your practice assignment is on Canvas. If you're in class, you're going to be working on that in class. If you're at home, please click on it, open it. There's just 8 questions. They're super easy. Here's the thing. You don't even have to solve anything on these. It's already done for you. You just have to decide if it's 1 solution, infinitely many solutions, or no solution. 8 problems. I need you to practice. Tomorrow we're going to do this again some more. And hopefully that's going to help you be ready for our assessment at the end of the week. Thanks for listening.